Welcome to MrCScience.com's video on experiment 2.2. You've just learned about ionic versus covalent bonds, and one of the ways you can tell an ionic versus a covalent compound is it will conduct electricity in water. So we're going to do an experiment 2.2 out of your book to show this. We're going to write up this lab just like we did the other one. All the labs going forward. So you'll need to either get out a new sheet of paper or your lab notebook, open it up to a new page, and let's start the lab. So at the top of the page, Roman number 1, title. Title of today's lab is going to be conductivity of ionic versus covalent solution. Sounds scary. Conductivity of ionic versus covalent solutions. But if your parents look at your lab notebook, they'll, ooh, look at that title, it must be important. Okay, go to the next line, Roman number 2. Purpose. All labs should have a purpose. Purpose of this lab is to test the theory that ionic solutions conduct electricity and I can't spell and covalent solutions do not. Long purpose. I'm going to leave the period off. Okay. Next line, 3. Hypothesis. Our educated guess. Our guess on this one is going to be a sodium chloride solution will conduct electricity, and a fructose, or not fructose, we're using sucrose. Sucrose solution will not. Okay. Okay. Roman numeral number 4. IV period. Materials. As I explained before, as per text, we're not going to waste time writing up all the materials. Roman numeral number 5, and again, if I'm going too fast for you, just pause the video and catch up. Procedure, same thing here as per text. We're not going to spend our time writing up a long procedure. Roman numeral number 6. Observations. This is where the magic happens. So, first couple observations, we're going to write down our things we know. We're going to be using sodium chloride, and we're going to be using sucrose, which is C12H22O11. So now what we know here before we begin, one of these is ionic, one is covalent. How can you tell? Well, an ionic compound has at least one metal and one non-metal. So, and a covalent compound has no metals. So if we look at our sodium chloride and you look at your periodic table of elements, sodium is in the first row, down 3 or so. It is in the metal area. So sodium is a metal. Chlorine is in that red area on the other side of the jagged line with the non-metals. So this, then, Control Z, let's try this again. Why am I, there we go. Sorry about that little delay. Is ionic, because it contains a metal. If we look at, same problem. There we go. If we look at our C12H22O11 sucrose, Those carbon, hydrogen, oxygen are all nonmetals, so this is covalent. Okay, so let's move on with our little operation. Let's go to our, oops, I left that wide open so you can see my superscript and subscript. Okay, let's go to our experiment. So here I got a couple beakers that have been cleaned. You may say, hey, this one right here looks a little dirty, but after a while they get little etchings and scratches and stuff, so it is clean. Been cleaned and rinsed with distilled water. So what we're going to do is we're going to fill up or put distilled water in both of these beakers. So if we grab our distilled water, it's easier if I grab the beaker. Don't need a lot. Maybe about half a beaker just to give us enough room to play with. We don't really care about the amounts. They should be about the same, which they are. If we hold them both up, they both about the same amount. So, okay, so now what we're going to do is we're going to take our battery, a 9-volt battery. Book warns you, do not use AC, do not use an outlet for this. It can cause major problems. So what we're going to do is I'm going to put these wires on the ends of this battery, and I'm going to fix it with tape. So let's, oops, I'm using the long end. I want the short. No, I do want the long end. Okay, trick here is to wrap the wire around the one post. Yeah, you guys don't need to watch me struggle with this. The key though is not to have the wire touching the other posts. So make sure we don't connect across there. We'll get what's called a short circuit. I'm not going to make you watch me struggle with this. So. And ta-da, it's like magic. The wires are attached to the battery, one to each terminal. So first thing I want you to see is, let's adjust these so they'll just kind of rest. Okay, so first thing I want you to see is a little fallacy. Water does not conduct electricity. Now, some people say, but wait, you know, you're supposed to get out of the lake in a thunderstorm, stuff like that, but if they were conducting electricity, what happens is the electrons from the water break apart the water molecule. And one side generates oxygen, one side generates hydrogen. So we should see bubbling if water conducted electricity. Now you say, well, why can't I stay in the lake when it's lightning out then unless it hits you right directly? Well, the caveat here is pure water does not conduct electricity. So distilled is pure water. It's 100% H2O. It might have some minor little pieces in it, but nothing major. So nothing really conducts. If you have ionic substances dissolved in water, then they do conduct electricity. So let's do our ionic substance next. So let's add some salt to our beaker and see what happens. So I got some sodium chloride. If I can open it. There we go. You say, where do you get sodium chloride? Well, you get it at the grocery store. And it's table salt. So I'm going to pour some sodium chloride in there, a decent amount. I'm going to stir it up so I can dissolve it. There we go. Now we'll let it stop. Now take a look what's happening. What do you see coming off of this terminal right here? Off that wire. You see bubbles. It is bubbling. So one wire is generating hydrogen, one wire is generating oxygen. It is conducting electricity. Okay. I'm going to stop for a second and rinse off my wire so that I don't contaminate my other sample with salt. Okay, the magic of video again. I rinsed off my wires and put them in the other one. So it's not contaminated. You'll see no bubbling around those wires. Let's go make our first observation. Or not our first one, but our next observation. So on your lab observations, we should see wires bubbled when placed in salt water. Okay. That's an observation. We're not going to talk about why or anything like that right now. It's strictly an observation. Now let's go back and do the same thing with the sugar. So here we are back here. Let's add some table sugar. Sucrose is table sugar is primarily sucrose. And we're going to put a bunch in there. I'm going to stir it up. So we dissolve some of it. Looks like we'll dissolve almost all of it here. Okay, what do we see happening? Nothing. No bubbles, no bubbles. So everything's all quiet. So that's our next observation. Okay. Wires did not bubble in sugar solution. Okay. So any other observations we should make? Let's see if you can see it here. I'll give you a little preview. It's all moving too much. You can see the wire, one of the wires kind of got blackened. That's a preview of what's going on, or might bring you back to your physical science days. So let's go ahead and finish our lab then. Okay, so we got all that, so let's go down and let's do Roman numeral number 7. Remember what I said? Conclusion is worth 50% of your lab. Okay. So, what do we do in our conclusions again? First thing we do is restate what happens. The wires bubbled in the salt solution. Now we're going to analyze that data, showing that they were conducting electricity. So the wires bubbled in the salt solution, showing they were conducting electricity. The wires did not in the sugar solution. So no electricity was conducted. Okay, so that's kind of what happened. I just showed you the water thing that doesn't relate to our experiment at all. But, okay, so now let's address our hypothesis. Our hypothesis is sodium chloride solution will conduct electricity and a sucrose solution will not. So, and why? So, we know that sodium chloride is ionic because it contains a metal, and ionic solutions conduct electricity. For the opposite reason, sugar did not. It is covalent, and covalent solutions do not conduct electricity. Okay, so that kind of explains it. Now our hypothesis was a sodium chloride solution will conduct electricity and a sucrose solution will not. So we can say, oops, I lost my cursor. There we go. Our hypothesis was correct. And once again, if you wrote down everything correctly, that's another 100% on your lab. So, hey, too easy 100% so far. In the near future, you'll be doing these conclusions on your own, so I've done enough to kind of give you an idea what's going on. In which case, then your 100% isn't guaranteed, but don't worry too badly. It's not that hard. So, okay, again, if you have any questions or concerns about this lab, drop me a line at mrc@mrcscience.com. Thank you.